Welcome to Lecture 6 of PS201 Seven-Step Problem Solving. This lecture covers Step 5 of the framework, Conduct the Analyses. The work plan is built, the ghost slides are drawn, and the owners are assigned. Now the analysis actually happens. This is the step where hypotheses meet evidence, where the structured thinking of the previous 4 lectures is tested against the real world. The quality of this step determines the credibility of everything that follows. Here is the course roadmap. We are 5 lectures into a 9-lecture course. Today we move from planning to doing, from specifying what the analysis will look like to actually conducting it. Ahead of us are 2 critical lectures, synthesis, which converts findings into recommendations, and communication, which delivers those recommendations to the people who can act on them. The quality of the analysis conducted in this lecture is the raw material for both. There is a principle that every analyst learns, usually through a painful experience: the quality of your recommendation is bounded by the quality of your data. You can have a perfect issue tree, a precise work plan, and outstanding synthesis skills, but if the data you feed into the analysis is incomplete, biased, or incorrectly sourced, the output will be wrong. Garbage in, garbage out. The research imperative is therefore not a bureaucratic standard, it is a direct constraint on recommendation quality. Source your data carefully, verify it rigorously, and know its limitations before you rely on it. All data collection falls into 2 broad modes: primary research and secondary research. Primary research means collecting data that does not yet exist in any form, through interviews, surveys, direct observation, or experiments. It gives you novel evidence that is specific to your question and your context. Secondary research means gathering data that already exists, in published reports, academic literature, company filings, or government statistics. It builds context quickly and at low cost, but it comes with an obligation: you must always check the source, the methodology, and the date. Never cite secondary data without understanding where it came from. The most commonly used primary research method in strategy and consulting work is the structured interview. Interviews are appropriate when the question is about perception, motivation, or qualitative judgment, things that cannot be measured by a spreadsheet. For Northmart, interviews with store managers would reveal operational realities that are invisible in the financial data: whether procurement processes are functioning, whether staffing decisions are driven by budget or by operational need, and whether frontline staff have identified cost drivers that management has not acknowledged. Design interviews carefully, use a consistent guide, and separate factual questions from evaluative ones. Surveys are appropriate when you need to collect comparable data from a large number of respondents efficiently. For Northmart, a customer survey could measure satisfaction levels, price sensitivity, and reasons for choosing or avoiding the stores, data that would take months to gather through individual interviews. The discipline in survey design is precision: every question must be unambiguous, the response scale must be consistent, and the survey must be piloted before it is distributed. A poorly designed survey produces data that looks quantitative but is analytically unreliable. Direct observation, watching how processes, customers, or staff actually behave, is an underused but highly effective method. It produces evidence that is not filtered through memory or social desirability, as survey and interview data inevitably are. For Northmart, a structured observation of the checkout process, the shelf stocking operation, or the goods receiving workflow would reveal inefficiencies that no one would volunteer in an interview. Plan observations in advance, use a structured observation guide, and debrief immediately after to capture what was seen before memory degrades. Experiments, controlled tests of a specific intervention, are the most rigorous form of primary research but are also the most resource-intensive. For Northmart, a pilot pricing change at 2 stores, with 2 comparable stores held constant as a control, would produce causal evidence about the relationship between price and volume that no amount of historical data analysis can provide. Experiments require careful design, appropriate sample sizes, and a clear protocol for interpreting results. They are most valuable when the question is causal, not just is there a relationship, but does this cause that? Secondary research begins with industry reports, publications from market research firms, trade associations, and sector analysts that provide data on market size, growth rates, competitive dynamics, and industry cost structures. For Northmart, a UK grocery sector report would provide benchmarks against which to compare Northmart's cost ratios and revenue performance. Always check the publication date, the methodology, and whether the sample is comparable to your context. Industry reports from 3 years ago may reflect a pre-pandemic market structure that no longer exists. Academic journals provide peer-reviewed evidence on topics such as consumer behavior, operational efficiency, and pricing strategy. They are most useful when you need to understand a mechanism, why customers respond to promotions in a particular way, for example, rather than a current market fact. Academic research tends to lag the market by several years, but its methodological rigor makes it more reliable than most industry publications. Cite academic sources when making claims about behavioral or structural relationships, not when making claims about current market conditions. Company filings, annual reports, accounts filed at Companies House, and stock exchange announcements are among the most reliable secondary sources for financial benchmarking. They are audited, standardized, and publicly available. For Northmart's cost benchmarking, the annual accounts of comparable grocery retailers provide labor cost ratios, occupancy costs, and operating margins that can be directly compared against Northmart's figures. The limitation is that the level of detail in published accounts is limited. You will not find store-level cost breakdowns, but you will find segment-level data that is sufficient for a high-level benchmark. Government statistical agencies, the Office for National Statistics in the UK, Eurostat in Europe, publish economic data that is highly reliable and freely available. For Northmart, ONS data on wage inflation in the retail sector, consumer price indices for grocery categories, and regional employment statistics provide macro context that no company dataset can supply. Government data is typically 1 to 2 years behind the current date, but it provides the structural backdrop against which company-level trends should be interpreted. Always cross-reference company financial data with the relevant macroeconomic context. Benchmarking, comparing Northmart's performance against comparable peers, is one of the most powerful analytical tools in this framework, but it is only as good as the peer group selected. The first step is to define comparators that are genuinely comparable, similar business model, similar geographic footprint, similar scale. A national supermarket chain with 500 stores is not a valid comparator for Northmart's 6-store regional operation. Define the peer group criteria explicitly before identifying specific companies, and document the rationale for each inclusion and exclusion. Once the peer group is defined, source the relevant data from the most reliable available source for each metric. For financial benchmarks, company annual accounts are the primary source. For operational benchmarks, industry surveys and trade association data may be required. For customer satisfaction benchmarks, published consumer research may be the only available source. Document every data source in the benchmark table alongside the metric, the date, and a note on the methodology used to calculate it. Undocumented benchmarks are analytically worthless. You cannot defend what you cannot trace. Raw benchmark comparisons are often misleading because structural differences between companies affect the metrics. A competitor with a higher proportion of freehold properties will have lower occupancy costs as a percentage of revenue, but that is a structural difference, not an operational one. Before drawing conclusions from a benchmark, normalize for known structural differences, adjust cost ratios for property ownership structure, for regional wage differences, for store size, or for product mix. Normalization is not always possible, but it should always be attempted, and the remaining structural differences should be flagged explicitly. The benchmark comparison produces a gap, Northmart's cost ratio versus the peer median, or Northmart's basket size versus a comparable competitor. Interpreting the gap requires judgment. A gap is not automatically a problem. Northmart may have a strategically different cost structure that is intentional and justifiable. But a gap that cannot be explained by structural or strategic differences is a signal. It suggests either an operational inefficiency or a pricing strategy that deserves scrutiny. State the gap, test whether it can be explained, and flag unexplained gaps as priority findings. In every real project, some data will be unavailable, suppliers will not share contract terms, competitors will not disclose their cost structures, and internal systems will have gaps. The first response to missing data is to identify a proxy, a related data point that can stand in for the missing one. If Northmart cannot access a competitor's labor cost data directly, the competitor's published labor cost as a percentage of revenue from their annual accounts is a reasonable proxy. Document the proxy explicitly and flag the assumption it requires. When a critical data point is missing and no reliable proxy is available, conduct a sensitivity analysis, run the analysis under multiple assumptions about the missing value, and test whether the conclusion changes. If Northmart's recommendation holds regardless of whether the missing supplier margin data falls within a reasonable range, the gap is not material to the recommendation. If the recommendation changes depending on the assumed value, the gap must be flagged prominently and the range of outcomes presented to the client transparently. Where data cannot be sourced and a proxy is insufficient, expert estimation is a legitimate substitute, provided it is clearly labeled as such. For Northmart, an experienced retail operations consultant may be able to estimate the likely range of shrinkage as a percentage of revenue based on comparable operations they have managed. That estimate is not as reliable as measured data, but it is more reliable than no estimate at all. Label every expert estimate as such in your analysis, specify who provided it, and note the basis on which it was made. The fourth response to missing data is the most important: acknowledge the gap explicitly in the analysis and the recommendation. Hiding a data gap, by omitting it from the analysis or by implying that the data used is more complete than it is a professional failure. Every analysis that rests on incomplete data must state which data is missing, what assumption or proxy was used in its place, and what the implication is for the confidence level of the finding. Explicit gaps are a sign of analytical integrity. Hidden gaps are a liability. Knowing when to stop collecting data is as important as knowing where to start. In structured problem solving, sufficiency is a judgment call, but it is not an arbitrary one. The first signal that analysis is sufficient is when the data consistently supports the hypothesis and additional collection is producing no new information. If the last three data sources all confirm that Northmart's labor cost growth is the primary driver of margin deterioration, and no counter-evidence has emerged, that hypothesis is well supported. Additional data collection at that point is not rigor, it is delay. The cleanest test for sufficiency is this: would additional data change the recommendation? Run this test explicitly before commissioning further research. If the answer is yes, if a missing data point could plausibly alter the direction of the recommendation, collect the data. If the answer is no, if the recommendation would be the same regardless of what the additional data showed within a realistic range, stop. The test forces a direct connection between data collection and analytical value. Data that cannot change the recommendation has no analytical value. Before moving to synthesis, every piece of analysis in the work plan must pass a quality check. The first two tests are: is the source of every data point cited explicitly, and has the logic of the analysis been reviewed by at least one person other than the analyst who conducted it? Source citation is not a formatting convention, it is the audit trail that allows any finding to be traced back to its evidentiary basis. Logic review catches errors in reasoning that the original analyst is too close to the work to see. The third test is: has the uncertainty in each finding been stated explicitly? Every finding should carry a confidence indicator, high, medium, or low, with a brief explanation of what drives the uncertainty. The fourth test is: does the output match the ghost slide specification? If the ghost slide specified a 12-month trend chart and the analyst has produced a single-period comparison, the output does not meet the specification. These four tests: source cited, logic checked, uncertainty acknowledged, output matches spec, are the minimum standard for analysis that can be used in a synthesis. The first takeaway: analysis quality is bounded by data quality. No amount of analytical sophistication can compensate for unreliable, incomplete, or incorrectly sourced data. Source your data carefully, document every source, and verify key data points against independent sources before relying on them. A finding built on shaky data is a liability, it will be challenged, and if it cannot be defended, it will undermine not just that finding but the credibility of the entire recommendation. The second takeaway: always match the research method to the nature of the question. Financial analysis for quantitative cost questions, regression for trend and relationship questions, interviews for perception and motivation questions, benchmarking for comparative performance questions. The wrong method produces the wrong evidence, and the wrong evidence leads to the wrong recommendation. The method specification in the work plan is your safeguard against this mistake. The third takeaway: acknowledge data gaps explicitly, and know when to stop. Missing data is a reality in every real project. The professional response is to document it, use the best available proxy or estimate, and flag the implications for confidence. And when the data consistently supports the hypothesis, an additional collection would not change the recommendation. Stop collecting and move to synthesis. Endless data collection is not analytical rigor, it is a failure to make the judgment call that structured problem solving demands. Here is the first discussion question. For the Northmart fixed cost analysis, you have decided to benchmark against 3 comparable grocery retailers. Define the peer group. Which 3 companies would you select, and on what criteria? What data sources would you use for each metric? And how would you normalize for the structural differences between Northmart's 6-store operation and a potential comparator with 30 stores? The second question. You are conducting the Northmart labor cost analysis and you discover that 2 of the 6 stores have not maintained consistent payroll records. The data for those stores is incomplete for a 12-month period. What are your options? Walk through the proxy, sensitivity analysis, expert estimation, and acknowledge and flag approaches. Which would you choose, and why? What would you tell the client about this gap? The final question. You have been collecting data for 4 weeks. Your 3 primary analyses all point to the same conclusion: Northmart's margin deterioration is driven by labor cost inflation in the store network, unmatched by productivity improvement. 2 planned analyses remain: a supplier benchmarking study and a customer satisfaction survey. Apply the would additional data change the recommendation test to each. Should you proceed with both, one, or neither? Justify your answer.